curve in it, and we also have that straight angle at the top, that straight right angle. So it's actually quite simple. We're going to use this point here. Again, we have to use a point that defines the circle. So we're just going to go up the length of 2, 1, 2, and then over the length of 3, 1, 2, 3, like that. So we have that right angle part of the triangle. And then we're going to trace the circle, just like from these points, going through all of them, all the way around, like that, like that, like that, to here. And we're going to stop. I'm going to stop right there. Okay, so that's it. So we're stopping on a point, we're starting on a point, and we have this angle here. And if we add up, we go 1, 2 plus 3 is 5. So there we have the length of 5 incorporated into the symbol. And this length distance between there is 4. We have the 2, a 3, a 4 between those points, and then the 5, the total 2 plus 3 again. So on the 5th circle, we're connected to points that define. We could actually draw a line if we wanted to through from this point through there, through here. That length has 3 units of the square root of 5 kind of built in as a straight line that can go through there like that. So if you're familiar with the square root of 5, as we just saw, you go over 2 and up 1. So the square root of 5 has a relationship to the rectangle. And there's a sort of a comment being made in the design of this that we have part of a rectangle here as the design. Just like in the square root of 2 that has a relationship to the 45-degree line, we have that angle built into the numeral for 2. Here we have a right angle and a part of a rectangle built into the relationship or the design of the square root of 5. So you see, you can kind of go across here and make these big rectangles like that if you want. And that's something that as we progress upwards with these circles, we see certain geometric patterns being able to fit inside them. So there we go. We have a numeral that is built on the circle with this radius of the square root of 5, and it contains the value of 5 within its dimensions. It's length of 2, and you add that to 3, and it's got the right angle and the rectangle. So that's why the numeral for 5 looks the way it does. Somebody who was aware of this geometry came up with that symbol. It's very different than all the others.